you, Laura, to continue here. Thank you for inviting me. Again, I'm very happy to be here, and I hope we can chat over a little bit on how this package might be helpful for you guys. And I'm happy to discuss and help in any way. As you say, my name is Magdalena Fuentes. I am a postdoc at NYU in the Marl group with Juan Bello. I am now working in environmental sound and sound event localization and detection, things like that. Before that, I did my PhD in France in a place called Telecom Paris. I don't know if you might know them. It's like people like Al Richard or Slim Asid. And my PhD was focused on music, actually. I come from the music information retrieval community. And before that, I was in Uruguay in South America, a small country over there. That's where I'm from. And what I'm going to present today, that's Sound Data, is it's an initiative that we've had jointly with Justin Salaman. You might know him as well. He's been all over the place as well and worked with many people, and he's working in bioacoustics as well, and is now in Adobe. I don't think he could make it today because it's very early there, but it also has some history that goes back to my PhD and my work in music, and I'm going to talk about that a little bit later as well. Feel free to ask anytime, anything. I'm learning how to present this package as well. So sometimes I'm wondering if it should be a hands-on thing, but then I don't know, maybe people don't want to go to a seminar and be asked to do stuff and like open a terminal and start doing things. So I try to do a like kind of hybrid thing, and also feedback on whether that works or not is very welcome. So let's get started. I'll start with the motivation of why this package exists at all. And I think that if you guys work with, which I think you do, with data and data sets and like real world data, you know how much time is dedicated, especially if it's like, if you build machine learning pipelines or like signal processing pipelines, a lot of time goes into putting the data in shape. And the thing is that if we are using the same data set, like the two students or like two postdocs, whatever, are using the same data sets nowadays, everyone writes the loaders and parses the data by themselves, meaning that the same code is written over and over again, which is not very efficient in terms of time. And it also means that there are different ways of loading that data, and that can introduce bugs, different versions in some cases. That happens a lot in music datasets, for instance, where there are copyright issues and you sometimes have to get the data by, for instance, buying a CD of Beatles, or like download, no, it's not a CD, but downloading it from somewhere in the web and then putting it together, and then you have the data set and you match it with the annotations, and it hopefully will work. So these kind of things happen. Not that much in the environmental community. I think the bioacoustics community also doesn't have this type of copyright issues, but the issues of waste of time and potential bugs and different ways of loading the same data remains. And that happens across the board in all data applications, let's say. So that was one of the reasons why we thought we needed to do this. And what Sound Data is a Python library that is, its objective is to facilitate the work with sound datasets. And Sound Data has a focus on environmental, bioacoustic, and 3D sound datasets. For now, I'm going to explain why this is like that in a little bit. So Sound Data is designed to be easy to use, easy to contribute to, because we want this to be a community, something that the community adopts and also contributes to. So it's useful for everyone. it aims at increasing reproducibility in the sense of if today I write a loader for a given data set and people start using it, we know when we compare in our papers or in methods or in new models that the data was loaded in exactly the same way and that it's actually comparable what we are doing. And it also aims to standardize a bit the usage of Soun datasets. Same reason, because of reproducibility, and in some cases, datasets need some sort of standardization. Again, that's more happens even more in music datasets, but it's never bad to have a standard way of loading, so you can reuse the code for several different datasets, and you don't have to write a different code for each of the datasets. So that's kind of like the overview of motivation of why we created Soun data. Just as an overview of what is there, Soun data has an extensive documentation with a lot of examples of how to use it, which I invite you to. We spend a lot of time trying to make that documentation as clear as possible and getting the different type of cases that will arise. So we hope that will work. And that's something that's continuously being updated. And we also did as a part of kind of almost as something that I wanted to have. And like my friends and collaborators, Rachel, Bittner, and Justin as well, is kind of this sort of table that tells you like, well, these are the data sets that we support. Hopefully that table will grow and serve as a reference for people that are starting in a field, for instance, where you can see what type of annotations it has, how many clips, how many hours, what are the licenses of those data sets, and that will facilitate navigating these resources that now are spread out everywhere, right? The history I was talking about, and it's a little bit of like following my own history on having worked in MIR and now working in environmental sound. Sound data comes originally from Mir Data. Mir Data is a package that we did with Rachel Bittner, who was also at NYU. She did her PhD here and is a friend of mine, and she's now at Spotify. And Mir Data was same idea as like a Python package to deal with music data sets. And that was something that we did while I was doing my PhD. Why did we decide to do Sound data inspired by and based on Mir Data? Well, first is because as I was working in environmental sound, I wanted to have the same API and the same package to work in music datasets and environmental datasets. And the thing about music datasets is that they're really complex in terms of annotations. For instance, they can have metadata about the instruments, the artist, the year it was created. It can have chords, it can have beats, it can have like really a lot of different type of annotations and a lot of data sets that have different ways of encoding the same annotations. So Mir data is really complex already, and we decided to separate Sound data because it basically environmental data sets are simpler, and that allows us to standardize more things and use other types of tools that are powerful as well. But if you go on the opposite trend that I did and decide to start working in music tomorrow, you can use the same API for Sound data and for Mir data. So let me now show you an example, okay? So it's like, this is me trying to show you a live example without making you code. What would you do if you want to use Sound data? So I hope you can see this, but basically you will go to Python, import Sound data, choose the data set you want, download that data set just by doing dataset.download. That will store it in your home, unless you pass a path. Then you can validate that data set, meaning that just check if downloaded okay and everything looks fine. getting a clip, either or a choice clip. And then you will get the labels and audio from the clip, as simple as doing clip.audio and clip. For instance, tags, labels, or whatever the annotations are. So it is quite simple in the sense of, if you know that you are going to work with ESC50, the syntax is always the same. You will do sound data initialize, and that will initialize your dataset for you, whatever the name of that dataset is. And then just doing dataset download, you'll get it. You'll get the annotations very simply. All good to hear?
Yeah.
Magdalena? Yes.
Can I ask you a quick question?
Sure. Who's speaking? Marcelo.
Oh, this is Marcelo. Yeah, I work with bioacoustics, so I'm not sure I understand what kind of data you guys work with. Like, if you can elaborate a little bit about the data and annotations that you are downloading.
Sure. I worked in the past, I worked with two big groups of datasets. Music, which are basically all concentrated in mere data. I'm not going to talk about that. And then urban sound datasets, you can think, or environmental sound datasets, such as like urban sound, AK, sonic USD, ESC50, and things like that. Usually, those datasets have a list of clips, audio clips, and annotations for each clip, let's say. Either they come in a big CSV file or they come in separated files. Those annotations usually are sound events. For instance, a clip will be annotated saying, at this time you have a siren, from this time to this time. At this other time you have a person talking, or at this time and this time there is an engine. And basically those are the most common formats of the datasets. Is this the question you were asking?
Yeah, exactly. Thank you.
What is the type of annotations that you guys have in BioacousTalks?
Well, no, the end is very similar. It depends what you do, but yeah, we want to know, we have some files, but from, like animal vocalizations mostly, and then you have annotations on where in the clips you have different species or individuals. Sometimes we have frequency range for those annotations. I guess that might be different, but yeah, it's pretty much the same thing.
Do you annotate, when you say frequency range, do you annotate a kind of the spectrogram with pitches, or you have a range of?
Yeah, like a box that has, the time and the start and end of the boxes in the frequency range would be, a box on the spectrogram, right?
Yeah, like a bounding box.
Yeah, exactly.
Okay. Yeah, right now in some data there are no bioacoustics datasets, just simply because we added 15 datasets that are the ones that we work more closely. But our intention is to see how we can add bioacoustics datasets, and in that sense, my hope is that you guys will give me some hints on that, or maybe you're interested in collaborating on that, and we can discuss on how to. I'm going to give it now a little bit of an overview of how we do manage internally these things, and we can discuss on how easy or is to add a data set, or like what would be the best way to go in that term, because this example I just showed for bioacoustic dataset will be exactly the same API, like exactly the same syntax up to. What it would probably be different is, I don't know if I can annotate. I don't think I can. I don't know if you see my pointer, but you do. But basically here, you will get this, the same way that you will get clip audio, but instead of clip, maybe tag labels, maybe you will get that, or maybe you will get clip dot frequencies or classes, or depending on what the dataset has. So the only thing that we would try to do is to think of, given different bioacoustic datasets, what are the commonalities, so we can group them and then use the same name basically for like the different tags or different frequencies, and then just like reuse the code to write the loaders for that. But we can discuss this a little bit more later if you want.
Okay, yeah, thank you.
Yeah. Thank you. Okay, so this is just one example of how you would start with Soun data, just downloading, validating the data set, and loading it in memory. I don't know, it's like, this is again the world that I'm the type of work that I'm doing right now. So the example that I brought is in urban sound classification, hopefully is close enough to bioacoustics that you guys can tell me what things would change and we can see. But in urban sound classification, for instance, what we would do is, okay, import like the evaluation tools that in our case Cerebral imports some data, and this is just because of how Soundeval needs things. Then you will have your model, which in our case is a random classifier that works awful. And the code that you will need to use to do a full evaluation of your data set using Soun data would be initialize the data set, load all the clips, and then just simply iterate on those clips and access the tags. So it's kind of very simple, and you can reuse this. I mean, for instance, doing this with Urban Sound 8K, but if I decide to evaluate on ESC50 or on any other Urban Sound classification dataset, I just change this, and the rest of the code remains the same. So that's kind of what we meant by standardizing and saving time for the evaluation. The rest of the code is just like building up the arrays and the dictionaries for evaluation. And this is again, evaluation isn't, this example is in the docs, but basically I imagine that if you have a similar structure for evaluating your bioacoustics, it's just a matter of writing the loaders and just calling the data sets here. So it kind of makes it quite easy or fast to prototype and evaluate things, but by using Soun data. Another example, I'm not sure how much familiar everyone is here with TensorFlow or like generators. I'm happy to stop or discuss more later if anyone has a doubt, but my intention with this example is again show you another thing that can be standardized using Soun data. So you can basically write a data generator in which you pass as a parameter the name of the data set, and then just use code from Soun data inside and just kind of like basically run your generator the same code for the different data sets again. So we scan or even call more than one data set in a loop inside. So it's another example that's in the documentation where you can train your deep learning model and just reusing the same code with Soun data. I'm gonna go to what the details are under Soun data, Soun data's API are now. I'm happy to go back to any of these examples if you guys want. So how is this structure under the hood? I'm just going to give an overview. So in case like, I think it's friendly to know how things work if you guys want to give it a shot and for instance, write a loader. So we grouped things in Soun data in three big groups, let's say. There is the core of Soun data, the utils, and the loaders themselves. The loaders are the ones that people will contribute the most. What is in the core of Soun data? where there's a dataset class that has all the information about the dataset that you might want, such as the name that you need to have for using it. But it has also information that you can do dataset.cite, and it will give you the citation, the bibtext to cite. You can do dataset.download, and we'll download it. You can do dataset load clips and things like that, and we'll load everything in memory. You can validate it. And then there is this index, which is what we use to create, to know where things are in the local machine, that I'm gonna just explain briefly later. So basically the dataset class is at the core, and is the same for all the datasets. And then we just instantiate that and like do write specific code for each dataset, but reusing, you don't have to write the download function. You don't have to write the load function. You don't have to write any of this because it's just already there for you to use. And the index is just, it looks like this. It's just like a way of organizing the data inside. Then here is, in the annotations, is where differences among data sets are encoded, let's say. So for instance, if we want to add a new data set that has annotations that are not supported right now in Soun data. Now we support tags. Tags is just a label at the level of the clip. Events is a label that has a beginning and end. And multi-annotator is just when you have an annotation that has multiple annotators. So it's like what each annotator said, just encapsulated in like a nicely way. So let's say you guys want to add, or like something frequency, or something that is unique to bioacoustics datasets and it's not in Soun data yet. What we would do is to add a class of annotations there. That the way that we're doing that is just we are helping the contributors, like not only in the discussion but also in the implementation. And we will add that as an extra class that will be used for all the datasets and so on. And then like the next person that comes to add a bioacoustics dataset will just have to reuse that class and no need to re-implement. Sorry, I went the other way. And then because most datasets right now are organized having clips, basically audio clips, we incorporated that in the core, and the clip is basically just a container for the audio signal that has the audio. You can access the audio from there, the annotations for that specific clip, the metadata for that specifically, just by doing clip dot, I don't know, labels or clip dot audio. So this is kind of like the overview of what is there in Soun data that can be reused for each of the datasets. The utils are just things. I think I'm going to just scan over this, are basically the functions that we use to support the core. So all the functions that do the download, that I don't know if you guys are familiar with jams. I don't know if it's very popular in bioacoustics. Never mind. It's like a way of visualizing data. We support jams, mostly because of many people in the urban community use it. But basically, the utils are just functions that help the functionality of Soun data. One that I like a lot, for instance, is the partial download. So, for instance, sometimes I don't want to download a dataset that's like 16 gigabytes if I don't know if it's going to be useful for me yet. So I can, if the dataset is loaded in Zenodo in a way that has the annotations separately, I can just do a Soun data download and pass the name of the portion of the dataset that I want to download, and I just download the annotations and start playing with it. And then if I want, as a second step, I can download the audio. So that's quite cool. The other usability we found with this partial download was teaching. Basically, in some cases, we made a sample data set of some of the data sets that are both in Mir data and Sound data. And that's basically, I don't know, like a subset that's 10 times smaller than the original data set. But you can, instead of downloading the entire data set, you can just download that. And it's really good when you're teaching in a hands-on class and you want them to download a tiny bit to get a hint of like what we're going to do, how you load the data, what the data feels like, how do we train a little model without having to wait for everyone to download a massive 1 gigabyte or like whatever science data set. So these are part of the utils these are mostly done by the core developers, but again, all data sets inherit them. So all data sets, as far as they have multiple files, you can download just 1 or 2 or whatever and use all these functionalities. And this is the fun part, which is the loaders. This is where the most contributions are done. And it's basically the code for downloading a specific data set. So what does this look like? Is basically when a contributor will like add a loader for a new data set, they will write this module in Python following the instructions of contributing, and they will add the code for specifically parsing the annotations for the data set that they want. And then that will be part of that will go through a peer review process I'm going to explain now, and then that will be part of the library, and that will be ready for everyone to use. And it's, again, as I said, like the most common and also valuable contribution for external contributors, because it's what first gives visibility to the data sets so other people can use them. It makes it easier for other people to use them and saves time. So how does the contributing pipeline looks like? It has a series of steps that sound more difficult maybe right now than they actually are. But believe me, like once you have done, for instance, one data set, it's like really following like a cooking recipe, because we kind of like made it clear what you put in each part, and it's not as I know it might be intimidating like this, but hopefully I'll convince you it is not. So the first thing you do is create an index. The index is that dictionary thing that I told you, which basically is just storing the information about the data set. It's storing the version of the data set, and it's storing the name of the clips and what files are linked to each of those clips. For instance, if each clip has audio and annotations on labels and metadata, and like has 2 files that are linked to that, this will look like audio, and then they will say metadata, and then will say annotation. And basically, it just has the path of like the structure you expect to have of that data set, and the MD5, the checksum, basically, to check the validation that all files are fine. So basically, to create an index, what you have to do is first have the data set locally in your machine, the data set that you want to have. That data set will have already a structure that the creators decided with folders or whatever files. And then you just have to list the files and create a dictionary on like what is there. That's an index. Is it clear? Do you guys have any doubt up to here? No? Okay, silence is Zoom is we are cool. So you created the index, you have this JSON file that's a dictionary with like what is in the data set. Then you write the model. A module is just a Python script, just like a .py script, in which you have, you will write the functions for loading the annotations of that dataset. Why you have to do that? Because it's the first time that this dataset is being added, and we have to do that once. But once it's done, next person that will use it will just like use your loader, and this hopefully is not going to be done again. So how do these functions look like? Just the same as you will do in like your work, which is like just parsing whatever the annotations are and saving it in variables. And in some cases, you need a custom download. For instance, there are some datasets that are not open access, that they require that you ask the creators. In that case, we just print a message and say, sorry, you have to contact this person to get the data. They will send you the data, and then you can use some data. But I don't know what is the case in bioacoustics, but in urban sound, luckily, that's not very common. In music, it is quite common. So, okay, you have the index that says what the dataset looks like. You have all the functions that load the dataset in the API of Sound Data. That's the fun part, that you create a test to check that these loading functions that you created work well, and we help with that as well. The docs are only README of the dataset and things that are related to the dataset. The docs about all the functionality of Sound Data are already there, and they are inherited by the loader, so that you don't have to care about. And then you've done this, you create a pull request in GitHub. We give you a template that has literally this checklist I'm telling you, and like this kind of like cooking recipe. So you can say, I've done this, I've done that, I've done that. And you submit your loader. We try to be very responsive, and luckily we had quite a response. So we've been adding datasets, not in the holidays. Now we stopped, but we are getting back soon. So this is a process that can go really fast if you need that loader. So let's say you submitted the loader, it can fail. And we have some hints on, depending on what fails, where is the error. For instance, if the build fails, we know it's something in the way that the load functions are doing, something's wrong. We help you figure that out. If it's you didn't write a lot of tests, because it's not very fun to write tests, we'll let you know. It's like, okay, you should add a test for this and that, and that will also be reported as coverage error. And if we really think that the docs are something super important in this project, so we have tests checking that you write the docs, and when you don't, they fail. So I know it's not it's always super nice to get to a project and see that everything is well documented, and you know why things are like that, and where so like we really emphasize that. And basically when everything is green, you can submit. So just as conclusions, I know this has been a lot of information on how things work under the hood. Hopefully I've convinced you that the code, that the repository and the framework of Sound Data is robust, that we test a lot, and we care a lot about having a complete documentation, and that is useful. Now we are always welcoming contributions and encouraging contributions. It would be great if we could learn from you guys what datasets would be useful in bioacoustics, what things, how is working with datasets in the bioacoustics community. And I'm also happy to answer any other questions and comments. And I want to thank all my collaborators, Rachel, Justin, and all the core developers that are great people that work a lot on these projects. And that's what I have to say so far.
Thank you very much. It's really interesting to see the parallels between domains and some of the differences. Are there questions?
Yeah.
I have a question, but I don't want to.
No, hop in. And
No, yeah.
also feel free to put
Break
questions.
the ice.
Well, thank you. That was very cool. And that was a high bar for presenting too.
Thank you.
But I wonder what kind of questions you envision the users of your library will have. You know, like what kind of result they're looking for when they're using your library.
That's a good question. The truth is, we are learning as we go a lot. We are sometimes changing some of the decisions we made early on based on what we see that people actually want. For instance, at the beginning, we were like, okay, we're not gonna add anything. We thought that if we added the missing part of loading easily datasets and obtaining easily datasets, then people will use things such as, I don't know if you know scikit-learn and like other frameworks, and they will use that for like randomly sampling data or like getting their splits or things like that. We noticed that people want everything solved in the same library sort of thing more and more. So we are changing this type of decisions. I think what people, my viewpoint is, I wish I had this when I was doing my PhD, for instance. I spent a lot of time writing loaders for data sets and trying to understand what was out there and what was the benchmarks and what was I doing when loading these things. So I think that for users that are at entry level and working with data, this is what they want, or these are like the questions that they have is like, what data sets are out there? How do I get these annotations? What happens with like the different ways of loading the annotations? For more advanced users, we have some functionalities to be able to work with data that's in a cluster, for instance. I don't know if that's the case for you guys, but some companies and like, for instance, a lot of the developers of this, of Mir data, especially work in Spotify, and they needed to load the data from like whatever cloud thing they have, whatever the deal they have. And we changed part of the API to support that as well. And honestly, we change things as we go, and we are counting on the community to ask what they need as well. So people open issues about, oh, I want an easy way to get a like random split from the data. Okay, go, like, we will help you write it, and then like they write it and add it in as a functionality. I guess that I would be curious to know what you guys want from a library like this. If this was Sound data bioacoustics, what does this how does that look like? What do you think?
Well, I don't know, but I guess like we could split the bioacoustic community in two, you know, like artificial, like
synthetic
groups, and yeah, no, like the people, the kind of questions that we do,
okay.
and there is a lot of well, we could say like trying to detect species, identify species in the data, and then things more related. Well, that's the way I see it, like with evolution and behavioral aspects of the acoustic data. And I'm coming more from the second kind of questions. So I feel like this, well, we are not that used to get annotated data from, you know, other sources and then apply to our research when we're working with things related to evolution and behavior and that kind of stuff. But I think we should be moving in that direction. So what I'm trying to say is like, I feel like it would be more useful for people doing, trying to train models to identify species, but I'm not very familiar with that. I feel like other people here might give
Just
you
out of curiosity, because I think I can understand better what people that are doing classification, how their pipeline looks like, because it's closer to mine. But what type of data do you guys use in the evolution side of things? Like, is it data that you curate yourselves? Or...
Yeah, most of the time. So we annotate the data, and then well, that's what we usually do. We get the data, download it, or get it from a library like Macaulay library, the one they have Cornell, and then we do manually or have some kind of supervised detection of the sounds there, and then with that we measure features on the sounds and try to understand, you know, compare them across species or individuals and that kind of stuff.
And does it make sense to, does it have value to share those annotations that you guys do for?
Yeah, definitely.
Then it
so
should
we
be in
have
some
been
data.
trying to, yeah, no, definitely. We have been pushing. I think Karen is here too. Like some more people. Like we have been trying to make those things available. So we have a lot of. So I have been doing this for a while, and our people too. So we start accumulating all these annotations, and we feel like, of course, it will be helpful for our people. You know, like I don't see the point of people re-annotating the same files over and over again, but we still lack the platform to do this kind of sharing. I mean, I think this is a good, that's an,
Yeah.
you know, like one way that we could do it. But sometimes what is hard is like, we are looking for, you know, like some recordings that they have some attributes, you know, from this place, from these dates and kind of stuff, that kind of stuff. So sometimes you cannot share the whole data set, and it's better to share single recordings with their annotations. Well, that's the way I see it. But yeah, I've been trying to do that and see we don't have it.
You know, like saving the distances, because it's really like a big jump, but this is reminding me a little bit of I did some music, some work in traditional music genres from Latin America, and the data there, it's extremely different from all of the other data, because the goal is different. It's not about training a like average model that will do average things in a collection of data, but like understanding a piece very well to get like conclusions of like about the culture and like the cultural trends of that music. And the annotations are complex, and the datasets are much smaller. But I do still think that's worth adding that information because of a couple of reasons. First, because it's a way of giving visibility to that. You don't like, I'm sure most people have no idea that you can do that with data, for instance. And it's like, if you add a data set, no matter how small it is, but with those annotations, you are also encouraging people to kind of follow that route, because you're making them aware that that exists, and that if they want to start working on that, they don't have to start from scratch, totally from scratch, which, believe it or not, I think that makes a huge difference for people adopting a certain research path or not, right? It's like, is there any data there for me to start? So not everyone is willing to do the data collection and annotation part. So I don't know, I would consider it as a possibility. Of course, I don't know much about it, but we are very happy. I mean, I want this library to be a tool for what makes sense and for the different cases of people. So I'm like really happy to help brainstorm things as well in that sense.
Cool, thanks.
I don't know if there are any other questions. I don't know if there are people that work on the more classification side of things that want to comment on this. Maybe they see some differences about from the environmental sound examples I gave, which I'm not very sure. Otherwise, that's fine.
I think one of the differences that crops up for me is the emphasis on spatial data, and we've touched on that a little bit, but a lot of our recordings have a place and a date that matters a lot as you're trying to coordinate and organize things.
There is data sets like that actually Sonic USC, which is a data set that we did in-house at NYU, is sort of similar to BirdBox in a way. I don't know if you know BirdBox, in the sense that it has the location and the timestamp of the recordings. So I think there is already a pull request open for Sonic USC, and I have to add another data set that's like mine, which is the same thing. It's a Musics of New York City data set, and it's like basically just a collection of music recordings from the sensors. So that might serve as a template, for instance, for one of those data sets. Maybe we can just reuse that code and simplify things. Maybe like a last question from me. What do you think, guys, is preventing people from like doing this type, like what would facilitate or like encourage people to share their data sets and write loaders in your community? What do you think that might be a blocker right now and that we could work on?
One of the things that comes to mind to me is that we haven't historically thought in those terms, like having a loader for a data set. We've mostly worked sort of at an individual level and not been focused on making things that other people could replicate that smoothly. So some of it's just the training and cultural awareness part. In my mind, I don't know what other people think would, seeing other people do it and having an understanding of what it adds versus, well, I just have the data on my computer, I can run this code and it works. Like what is this other thing that I'm building? I think would be one of the hurdles to getting people into that framework.
Yeah, it makes sense. I think it's been the same for the other communities as well, actually. It's not something that we are getting more and more used to sharing models, because it's kind of becoming now conferences kind of like look down at you if you don't provide some code or some repository. But in data sets, it was not the case at all in other communities as well. So I think that's a fair block to have. What data sets do you guys think that would be, I'm gonna make a, how do you say, like kind of weird question. What data set, if you have to pick a couple of data sets that are the most used in the community that could like be encouraging for like, look, these data sets are out there, maybe I should put mine there. What those would be, and you can self-promote data sets if you want to.
Others should jump in, but my sense is that a lot of the most shared data sets are marine. The marine passive acoustic recording has matured faster than the terrestrial. Historically, it was expensive and difficult to do these long-term recordings. So the marine people were the ones that had the biggest incentive to do it. And then it's really been in the last maybe 8 or 10 years that we're getting big terrestrial acoustic data sets. So when you ask, like, what are the ones that everybody uses, it's a pretty short list. There was a competition, a Kaggle competition this past spring for bird call identification, and there are a few data sets that went into that. But I don't, in the way that some fields have a core of, oh yeah, everybody tries things on this data set. I don't think we have that as much. Others should feel free to jump in if you have ones that come to mind.
I feel like for the things that we have done, that we end up with lots of, well, we use a lot of recordings, different species, and lots of annotations. So something that we feel we cannot make us feel that we cannot share that data is that we are getting those recordings from a third source. Like I told you, like you know, an online library or Macaulay library, we have to ask permission to get those data sets. So we don't feel like we can share it, right? Because it's not our data. We're just, well, at least some of those recordings, or most of those recordings would be somebody else's, and you know, like to do a copy of that, we feel like we cannot do that. So that's what we feel like, maybe sharing the annotations and linking those annotations to the recording source might be a way to do it, but I think that could be precluding people for sharing like, things as the ones that you showed.
No, yeah, I think that's a like really important point, and that happens a lot in the music data sets. Actually, we have in Mirror Data many, basically most music data sets are commercial music that you hear in the radio and stuff like that. No researcher owns that music, and no researcher has the right to share that music in a way that's proved to be kind of like, you know, there is not even a law that allows you to kind of like use it for research purposes. That you have to kind of like trim the clip and stuff like that. So what people do is that they still annotate the data, and they share the annotations with, like, as you're saying, with a link of like, basically that's the cases in which we have customized download functions for the loader, in which we print a message saying, you can get the data from this resource or this website or like contacting this person, but here are the annotations. So as far like as you go and contact that person, get the data, you can use the data set anyway. And that is how it works for many music data sets. So maybe it's worth reflecting about it and giving it a shot in that sense moving forward. Happy to brainstorm on that.
So I have a basic question. So whenever
Yes.
you just annotate a song or annotate a soundtrack, like you are working on that urban classification, urban soundscape data classification. So you did it in manually, right? Or you just use some training?
You mean if the annotator has, if we do it automatically or if it's manual?
Yeah,
We support both annotations. Most of the annotations that they are in place are manual, and okay. in some cases, the person that's loading the data set, either the data set doesn't have manual, or they want to add synthetic or like model produced annotations. And we have a confidence, you can even add the confidence of the model in the annotations as part of the annotations. So we support both, with the caveat of knowing you are using manual annotations, you're using machine generated annotations.
Okay. Thank you.
Yes, I could. No, thank you. I don't know if anyone has any further questions. I do not. I think I've got a good idea of many things.
Thank you very much for the information. It's really interesting to see the different versions and the emphasis and how they're put together. I could see that being really useful for the community.
No, that's fine. And I hope I will probably reach out to you guys later this year. I really hope we can take a step towards adding this bioacoustics in a way that it's useful for the community. And for that, I will need your help and input. So thanks for reaching out and giving me the chance to introduce this to you.
Absolutely. Take care. Thank you very much.
Take care, everyone. Nice to meet you. Bye bye.
Thank you.